Hello there. Today we'll be doing a string isomorphism. Given a lowercase alphabet string S and T, return whether you can create a one-to-one mapping for each letter in S to another letter, could be the same letter, such that S could be mapped to T, with the ordering of characters preserved. An example, let's talk about the constraints. So the constraints are that n is less than 100k, where n is the length of S, and m is less than 100k, where m is the length of T. So in example 1, Coco and Kaka is true because you can convert C to K and O to A, while you cannot convert C, cat, and foo, because you cannot transform A to T and into O, A and T into O, since it's not a one-to-one mapping. So let's get started with this problem. First, we're going to make this work, then we're going to make this right, and lastly, we're going to make it fast. Alright, so what I can see here is that I tested that these they must be the same length earlier. So if they are not of the same length, let's say COCOC, we try that test case, and Kaka, this particular item here, we should return false if they are not of the same length. According to this problem, as you can see, this is true. This is false. So what we've learned here is that we don't do that. We have to make sure that they're the same length. Why? I'm not so sure, but I think it has to do with the mapping. So I'm going to return false if they're not the same length. Alright, so they must be the same length. So length of n is the rate length of S. And we're going to create we're going to go through each item of n. And this will be for both the S and the T. So if S, so we need to create some dictionaries, and we want to map it from the S to the T, but at the same time we also want to match it from the T to the S. The reason for this is because if you look at cat, you can match C to T, A to O, and T to O. But when that happens, as you can see here, dictionary S of I, we can also make that char S, and char T is equal to T of I. If you look at char S, you make sure that this is in the dictionary. If this is in the dictionary, then we want to make sure that char S, dictionary of char S, is equal to char of T. Else does not equal to return false, because if they are not, if this is if they we found a single item that is not equal to T, which we have assigned already down here, If it's not in the dictionary, then we should assign it. Otherwise, we check if it's in the dictionary, and if it's not equal to the item, then the char t, then we return false. But this particular situation can match. This would be true for cat to foo because we can assign a to o and t to o. But on the converse, we do not check if o can be mapped to a and t. So that's where the discrepancy is. So we need char t in dictionary 2 if dictionary 2 char t does not equal char s, which is we assigned 0 o to a already, but we have a problem with a t because we check, oh look, it's in the dictionary, so let's check out what it is, and char s is now t for dictionary 2 of o, then return false. Else just add this to dictionary and we'll keep going. So after all of this, we can just return true because the mapping has succeeded. Looks like a little error there. Another error there, and looks like we're doing good. Let's check out the solution right there. As you can see, success 100%. A way we could make this a little bit shorter, but a little bit slower, because currently we're running at O of n, which is we're doing one loop of the length of characters because we're using the index to match both. Of course, this would not work if they were the different length. So what will happen is that we could do use some of the functions available to us. So if we do we can do a return string translate of the string make trans of s and t. So what make trans does here, it creates a translation of s to t, create that string, that sort of mapping, and s dot translate is that we change we make that translation from s to t and set that to be equal to t. And if the length of the set of s, so now that it has been translated, let's check if they are of the same length, that they have the same unique characters. If they do, then we can return true because everything translated over properly. So we run this. Let's see. Right. So this also gives us a correct answer here. One thing to note is that this does not take care of the strings of different length. As you can see here, there's an error. This is because make trans needs arguments of 2 equal length. So what we can do is do a try exception block here, and return false if they're not. If there's an exception, and that should clear up that issue. Right. So I think that makes it as simple as possible, but I think this problem, there seems to be one issue that we're not taking into account of, is if they are of a different length. I believe that should be able to map over, but otherwise I think the bottom solution covers that. Anyways, that is the solution to string isomorphism. If you have any comments or questions, please post them below in the comments section. If you like the video, please like the video. And if you like more of these videos, please subscribe. Thank you very much. Have a good one.